Good morning, friends. Myself, Dr. Pramod Musrif from AISSMS Institute of Information Technology, Assistant Professor in Engineering Physics. Today, we will see about the properties of the lasers. So, what is light? First, we'll see what is light. So, how we are getting light? Atoms, when they absorb the energy, jumps into the higher energy level. But since it is not the stable state, they come to lower energy level. And while coming from upper level energy level to lower energy level, they emit the photons, which are known as the packets of energy, and this stream of photon is nothing but light. What are general properties of the light? Light is a wave having the properties wavelength, frequency, period, speed, amplitude, intensity. Light is an electromagnetic wave. So the light is associated with electric vector and magnetic vector, which are perpendicular to each other, as shown in this diagram. Now, what is laser? Laser is a special light. It stands for light amplification by stimulated emission of radiation. Laser is a device that produces a coherent beam by stimulated emission of by electronic or ionic or molecular transition to higher energy levels. When they return to lower level by stimulated emission, they emit the energy. We'll see the history of laser. Laser has been invented in 1958 by Charles Stones and the Arthur Shallow from Bell Laboratories. But the idea of the laser has been given by the Einstein from the particle wave duality of light before 30 years earlier, and which was called as a measure. M stands for microwave. In day-to-day life, we are using laser as a laser printers and laser pointers. Properties of the laser are like this. The laser is having a property. It is a monochromatic light, highly directional beam of light. All the waves of the light are coherent, and the laser is also having the high intensity. So these all properties of the laser make the laser as a special light, and one by one we will see the properties of the laser. What do you mean by monochromatic? So monochromatic means a single wavelength or very small difference between the waves of the light. For example, helium neon laser is having the wavelength 632.5 nanometer with a difference of 0.2 nanometer. Diode laser 900 nanometer with a difference of 10 nanometer. These are the two waves, blue light and red light. So we can see here the wavelength of blue light is less and wavelength of red light is more, and both of them are means monochromatic. Coherent, if you see the second diagram, all the waves are in a phase, means crest of one wave is matching with the crest of one another wave, and trough of one wave is matching with the trough of another wave. Whereas if you see the first diagram, that is incoherent source, so phases are not matching, and whereas all the waves are with different colors means not mono. Directionality, if we see the normal light, normal bulb, all the waves travel in all possible directions. whereas laser travels in single direction with a very less divergence. This also diagram shows the coherent source, monochromatic source, directionality properties. So in this way, laser is characterized by a coherent beam, monochromatic beam of light, intense beam of light, and unidirectional beam of light. Thank you.